Okay, so today I'll be going through the 2024 Read Swastika P5 WA2 paper. Okay, so let's start. Okay, question 1. What is the value of the digit 3 in 23,195? So we're looking at the digit 3, right, which is here in a thousands place, so that our answer, the value will be 3,000. Okay, so it'll be option 3. Question 2, round 5.646 to the nearest tenth. So 5.646. The nearest tenth, right? 10 is in a one decimal place, meaning I have to look at a number after that, which is 4, to determine whether I round up or down. So 4, I will round down, meaning 6 I'll still remains as 6. So my answer will be 5.6, okay, which is option 1. Question 3, arrange the following from the largest to the smallest. So looking at all this is 0.103. So this is 3 decimal place. This is 0.013, which is also 3 decimal place. This one is 0.03. This one, so to make it all the same decimal place, I should add one more 0 behind so that I can see it easily. Okay, so the largest one will be this one, followed by this, and then the smallest one will be this one. So looking at my 4 options, my answer will be option 2. All right. Okay, let's move on to the next question. The following cuboid is built using 1 cm cubes. What is the volume of the cuboid? So here, right, 1 cm cube, right, the volume of 1 cm cube, 1 is just 1 times 1 times 1. Length, breadth, height is all just 1 cm. So that will still be 1. So in order to find the volume of the cuboids, let's just count total how many cuboids are there. The easiest way, right, is to find out the length, breadth, and height, then multiply together. Okay, so lengthwise, I have 1, 2, 3, 4, 5, 6. Okay, the breadth-wise for this cuboid, that's 1, 2, 3. The height is 2. So to find the total number of cubes in this cuboid, it will just be length times breadth times the height. 6 times 3 times 2 will give us 36, which is option 4. Okay, so question 5, it's a ratio question, so I'll skip this question. Okay, then we can move on already. Okay, let's do question 6. Okay, 6a, write 24,050 in numerals, means write in numbers. Okay, so 24,000. Okay, so by right, you have 3 zeros behind, right? But because of your 50, it will just be like this. Okay, the 50 will take in a tens place. So this is your answer for 6a, 24,050. Part B, what is the remainder when 3,406 is divided by 7? Okay, take note, for this paper, you're not allowed to use your calculator, so you have to do your long division. So let's do it together. So 3,406 divided by 7. So 3 cannot divide by 7, so I'll straight away take 34 divided by 7. I'll get 4, which is 28. So I subtract, this will become 14, this one is 2. So 14 minus 8 will give me 6, so 0. I bring down the 0. 60 divided by 7 will give me 8, which is 56. Okay, so this one become 10, this one is 5. 10 minus 6 will be 4. Okay, this one will be 0. I bring down the last digit, 6. 46 divided by 7 will give me 6, which is 42. Okay, 46 minus 42 will just be a 4. So my remainder will be 4. So for this, your answer will be 486, remainder 4. The question is asking for remainder, meaning my answer will be 4. Okay, let's move on to question 7a. Find the value of 15.14 minus 7.89. Okay, so same thing. This one you're not allowed to use your calculator. So let's compute it together, the working at the side. Okay, minus 7.89. Okay, so 4 cannot minus 9, right? So we group, this one becomes 14. 14 minus 9 gives us 5. Okay, 0 cannot minus 8. So we regroup, this one becomes 10 minus 8. That would be 2. Okay, 4 cannot minus 7, so I do again. It becomes 14 minus 7 will give us 7. So 0 minus nothing will just be 0. So for this, our answer will be 7.25 for question 7A. Okay, let's move on to question 7B. Express 0.28 as a fraction in the simplest form. So for this one, this decimal is 2 decimal places. Okay, so it will just be 28 of 100. Okay, anything in 2 decimal places, you can just put it the number of 100. Okay, and then this one will be given in simplest form. So 28 and 100 both I can divide by 4. So 28 divided by 4 will give me 7. 100 divided by 4 will give me 25. So for students who actually did divide by 2 and then divide by 2 again, you will also get the same answer. Okay, so just make sure you check whether your answer is really in the simplest form. Okay, if not, you have to continue dividing. Okay, let's move on to the next question. Question 8, study the following solid. So you have your top view, front view, and your side view. Okay, so the question wants you to draw the top view. But make sure when you draw your top view, right, you have to make sure here, this orientation here, you have to draw it such that here is from your front. Okay, here is from your front. Okay, so looking at the top view, the first column I have 1, so I'll draw 1 here. Okay, and then my second column there is 3. So I'll draw 3 squares. Okay, take note when you are drawing on your own paper, right? You have to use ruler, okay? And then yeah, and then this 3 squares, and then the last column here I have 1, but it's connected to the second one, so it's like this. Okay? Yep. So this is my top view. Okay, and then this is from the front. Okay. Then let's look at part B. What is the least number of unit cubes to be added to the solid to form a cube? Okay, you want the least number of unit cubes, okay, to be added. So we look at this one. For unit cubes, right, you can make either 1 by 1 by 1 cube. But you see, your length, right, is already 3. Okay, 3 cubes. Your breadth is already 3 cubes. Your height is 2. So it's definitely not possible to form a 1 by 1 by 1 cube already. So this one is not an option. Okay, the next biggest one will be a 2 by 2 by 2 cube. But like I said, your length is already 3, your breadth is already 3 already. So this 2 by 2 by 2 cube is also not an option. So your next possible one will be 3 by 3 by 3 cube. Okay, so for this, yes, you can, because your front view is 3, sorry, not front, your length is 3 cubes, your breadth is currently maximum of 3, and then your height is 2. So it is possible to make a 3 by 3 by 3 cube. Okay, and this is the smallest possible option already. Okay, so let's find out how many unit cubes we need to form a 3 by 3 by 3 cubes. You just take 3 times 3 times 3, we will get 27. So we need 27 unit cubes. Currently, you count how many are there here. We have 1, 2, 3, 4, 5, 6. Okay, so you will need 27 minus 6, which is 21 more unit cubes to form a 3 by 3 by 3 cube. Okay, so your answer is 21. All right. Okay, let's move on to the next question. Okay, question 9, it's a ratio question, so I will skip that question. We'll move on to question 10. So the diagram below shows the cost of a watch before GST. What was the price of the watch after adding 9% GST? Okay, so if the question, you need to know before GST, right, which is here, $200 is always the original, which is 100%. Okay, the base, okay, the original price of a certain item is always the base, which is 100%. The question is asking after adding 9%, which is in addition to the 100%. So you're actually looking for 100% plus the 9% GST. Means you're looking for 109%. Okay, so for this question, we know that 100% is $200. So let's write it down. 100% is $200. So we will use the unitary method, which is like finding units. So for unitary method, right, always have to find 1 unit. So for this case, you have to find 1%. Okay, so same thing, you take 200 divided by 100. 1% will be $2. And then remember, we are looking for the price after the 9% GST, which is 109%. So to find 109%, I just take 109 times $2. We will get our answer, $218. Okay? Okay, so with this, let's go to the next question. Question 11. A cubical container of edge 10 cm is 4/5 filled with water. How much more water is needed to fill the container completely? All right, so currently this container here is already 4/5 filled. So I want to find the fraction that I need to fill up. How much more I need to fill up? Okay, so the total, right? One hole is 5 out of 5. Currently it's already 4/5 filled, right? So the fraction that I still need to fill it will be 5 minus 4 5 will give me 1 out of 5 of the container. So I just need to find 1/5 of the volume of the container to find how much more water I need to fill the container completely. So I will just take 1/5 multiplied by the volume of this container, which is 10 times 10 times 10, because this is a cubical container, so the length, breadth, and height will all be 10 cm. Okay, so this one, right, 10 times 10 will give me 100. 100 times 10 will give me 1000. 1000 times 1/5, right, is the same like 1000 divided by 5. So my answer will be 200 cubic centimeters. Okay? Okay, next. Let's move on to question 12. Sorry, let me clear my drawings first. Let's move on to question 12. Amy mixed 1.2 liters of blue paint with twice as much red paint to get purple paint. She then poured the purple paint into 100 small containers. How many liters of paint were there in 20 such containers? Okay, so what Amy did is she mixed 1.2 liters of blue paint with twice as much red paint. So for this, it's like blue paint is like 1 unit, and then for red paint, since it's twice, it'd be like 2 units. Okay, she mixed this blue and the red paint to get your purple paint. Then she poured all the purple paint into 100 small containers. The question is asking you for how many liters of paint were there in 20 such containers. Okay, so first thing first, let's find the total purple paint. Okay, so you know the blue paint is like 1 unit is 1.2. Mixed with 2 liters, so total, not 2 liters, 1 unit, and then mixed with 2 units, right? So total you will get 3 units. So to find the total purple paint, I simply just take 3 times my 1.2 liters, okay, because 1 unit is 1.2 liters. So 3 times 1.2 liters, I will get 3.6 liters. So she poured all the purple paint into the 100 small containers, right? So I'll write down 100. Okay, the C here represents the containers. It's 3.6 liters. Take note, the question is asking how many liters are you have to leave your answer in liters, so do not need to change to ml. Okay, we will leave it as liters. How many liters were there in 20 such containers? So usually you might want to find one container, then find 20. Okay, but for this paper, right, we are unable to use the calculator. Okay, so what I will do instead is from 100 to 20, right, straight away, you know that from 100 containers to 20 containers, you divide by 5. Okay, so for this, if you divide by 5 on the left-hand side, my right-hand side, I just simply do the same thing. I also divide by 5. So 3.6 divided by 5, what I will do, I have to do my long division. Okay, so 3, I'm unable to divide by 5, so I put a 0 here. Okay, so I subtract, it will still be a 3. Okay, bring down the next number, which is 6. 36 divided by 5 will give me, remember to put your decimal place here. 36 divided by 5 will give me 7, okay, which is 35. Okay, so 36 minus 35 is 1. Okay, take note, you cannot have remainder for this question because you have to account for all the paint. Okay, so what you will do, you add a 0. Okay, continue the long division, bring down the 0. 10 divided by 5 will give me 2. Okay, so you subtract and then that's all. You have no more remainder, and your answer is 0.72 liters. All right, okay. Let's move on to our next question. Okay, question 13 is a ratio question as well, so I'll skip that question. We'll move on to question 14. The figure shows the amount of water in two rectangular tanks A and B at first. Tank A was filled to the brim and there was some water in tank B. So part A, you want to find the volume of water in tank A at first. So tank A is filled to the brim, right? So to find the volume, just take the length times the breadth times the height. Okay, 6 times 5 gives us 30. 30 times 12, this one we have to do our working. Okay, 0 times 2 is 0. 3 times 2 is 6. 0 times 1 is 0. 3 times 1 is 3. So you add this together, you will get 360 cubic centimeters. Okay, remember your units are because this one, you have to write down your own units already. Okay, then part B. Mrs. Lin poured 1/3 of the water from tank A into tank B to fill it to its brim. So what is the volume of tank B? Okay, so you look at tank B. Tank B currently has some water. Okay, then we just need to pour 1/3 of the water in tank A into this. Okay, 1/3, which is somewhere here. We are able to fill it to the brim. So in order to find the volume of tank B, I just need to find this volume here, which is the 1/3 of A, and whatever the water which is already in B, add them together. Okay, so first thing first, let's find 1/3 of the water in A first. We have already found A is 360, right? So to find 1/3, I simply take 1/3 times the volume in A, which is 360. So 1/3 times 360 is like 360 divided by 3. Okay, we will get 120 cubic centimeters. Next, I find out how much water is already in tank B. I just take length times breadth times height of the water. So that will be length, which is 10 times 4 times 4. 10 times 4 will give us 40. 40 times 4 will give us 160. So, like I said, this is from tank A point inside. This is already in tank B. To find the volume of tank B, I just add up these two together. So 120 plus 160 will give us our answer, 280 cubic centimeters. Okay? Okay, let's move on to our next question. Okay, question 15, the participants of a race are divided equally into Group A and Group B. Group A has 20 more boys than girls, while Group B has 12 more girls than boys. 45% of the participants are girls. Part A, what percentage of the participants are boys? So take note, the total, okay, is always 100%. Okay, so if they tell us the participants is for girls is 45%, to find the boys, we just take the total minus the girls, which is 100% minus the 45% for girls. It will give us our boys is 55%. Okay, so pretty straightforward. This is a 1 mark question. Okay, just 55%. Okay, part B, how many participants are there in each group? So this question has two groups. One is group A and one is group B. So it tells us that group A has 20 more boys than girls. So I will draw a model to represent this information. So group A, boys and girls, right? It tells me that group A has 20 more boys than girls, like this. Okay? And then for group B, 12 more girls than boys. So I'll draw another model representing group B. This time round, the girls is more than the boys. Okay, so I'll draw boys shorter. The girls will be slightly longer. Now I'll label it 12. Okay, so group A, there's 20 more boys. Group B, there's 12 more girls. So if we look at overall, right, if we add all the boys and girls together, actually, the boys will still be more than the girls because this one is 20, this is only 12. So 20 is bigger than 12, right? So overall, how many more boys will there be more than the girls? I just take 20 minus 12, will give me 8. Okay, so actually overall, there's still 8 more boys. Okay, and then next, remember in part A, we found the percentage of boys is 55% of the total. The girls is given in the question as 45%. Okay, so I want to find the percentage difference between the boys and girls. So boys is 55%, girls is 45. So I take 55 minus 45%, it will be 10%. Okay, so this is the percentage difference between the boys and the girls. And then 8 is the difference, actual number of participants, difference between the boys and the girls. So this 10%, okay, will be the 8 boys that is difference. Okay, then for this, we can straight away, I want to find how many participants in each group. Let me find the total participants first. Okay, so the total participants in both groups will be 100%. Like I said, the total is always 100%. So from 10% to 100, right? Remember this one, you can just times 10. Okay, meaning on the right hand side, I can also times 10. So it will just be 8 times 10 will give me 80. So in both groups together, two groups, okay, two groups together is 80 participants. At the first sentence, they tell us that the participants are divided equally into group A and group B, meaning A and B has the same number of participants. Okay, so since total is 80, if I want to find one group, I just simply take 80 divided by 2. I will get 40 participants in each group. So that's my answer, or 15B. All right. Okay, with this, let's move on to the next and last question, which is question 16. Okay, Miss Wong had packets of two different sizes, large and small. She filled 3 large packets and 5 small packets to their full capacity with 7.2 kg of rice, which is here, the 3 large and the 5 small. Total is 7.2 kg of rice. So Miss Wong could not fill another large packet with the remaining rice as she was short of 0.5 kg. Instead, she filled another small packet and had 0.3 kg of rice left. So actually this question tells us two scenarios. Scenario one here is she cannot fill another large packet. She's still short of 0.5. Then the second scenario is she can fill another small packet but still have 0.3 kg of rice left. Okay, so actually this question has two scenarios, and in both scenarios, Miss Wong's rice, right, must be the same mass. So I'm gonna draw it out. Let me shift it down a bit. Her rice must be the same mass for both scenarios. So let me draw it. Okay, so she say, right, in both, she's able to fill up the 3 large packets and the 5 small packets. But in the first scenario, okay, so this one, right, let me write down this as, this one is for 5 large plus, sorry, not 5 large, it's 3 large, 3 large and 5 small is 7.2. Okay, she could not fill another large packet with the remaining rice as she was short of 0.5 kg. So in order to fill another large packet, okay, this is one large, she still needs another 0.5. That's why I added another 0.5. Okay, second scenario, she also filled up the 3 large and 5 small, same as the first scenario. 3 large plus 5 small. Okay, but in this time, she filled another small packet and had 0.3 kg of rice left. So she can fill up one more small. Okay, but in this case, she actually had rice left and 0.3 kg will be the left over here. All right, so what I'm going to do now, I will look at the part whereby it's different, which is over here. The one large and the one small. One large is from here all the way to the end. One small is just this one small here. So the difference between one large and one small is actually from here to here. Okay, this is the difference between one large and one small. All right, so let me just write it down. Difference between one large and one small will be 0.3 plus 0.5. Okay, because it's a difference, we will get 0.8 kg. 0.8 kg difference, right? So now remember at the beginning here, we already know that 3 large and 5 small is 7.2. So let me draw a stacking model to represent this, okay? For those who cannot see, but for those who can see, actually you can just straight away do your working to find the final answer. So for me, I'll have 3 large, so I'll put 3L, and then 5 small, right? I'll put 5S. Right? So the large is how much more than the small? It's 0.8 kg. So I'll draw each large bigger than the small. Okay. Each one is 0.8 kg bigger than the small, like this. The small will just all be 1 unit here, like that. The same length. 1, 2, 3. Okay, so this is 3 large and 5 small. Total mass is 7.2 kg. I will label like that. Okay, so from this model, you will see that the extra is this 3 here. So I'll take 3 times 0.8. It'll bring me 2.4. This is the extra. So what do I do with extra? I have to subtract from the total. If I subtract from the total, I'll get 8 units. Okay, so 8 units will be 7.2 minus my extra 2.4. We will get 4.8. Okay, always find 1 unit. You take 4.8, divide by 8. We will get 0.6. Okay, so the question is asking how much rice were there in each small packet, which is actually 1 unit, right? But the question is asking to give your answer in grams. So currently all my values here are in kg. So I have to convert this 0.6 kg into 600 grams. So my answer for question 16 will be 600 grams. Okay, so I've come to the end of this paper. Thank you.